All right. Okay, so yesterday we graphed them on the calculator. This is what they look like. And then we answered some questions on there, right? So we answered these questions here, A, B, C, and D. All right. Correlation is 0.777. There is a positive, moderate, or moderate to strong linear association or correlation. We got the predicted height. So the predicted height is equal to 54.071 plus 1.462 times shoe size. The slope was 1.462. So for every one shoe size increase, you're going to increase height by about 1.462 on average. That's not for everybody, but that's just based on the data. When shoe size is 0, your height is going to be 54.071. That doesn't make any sense. Sometimes they don't, but that's the interpretation. Okay, so that's how you interpret that. All right. So we have the equation, right? We have the equation of the least squares regression line right there. That equation right there, right? That's how we got A, B, and R, right? That's how we got A, B, and R. So today we're going to talk about how did they come up with that equation? So that equation, how did our calculator come up with that equation? So what that equation means is, what line would best suit the data? What line would best fit the data? So would the line look like that? Would it look like that? Would it look like that? How would it best fit the data? There's a lot of options there, but the one that best fits every single one of these points, not just a few of them, like these down here are a little low. These down here are a little low, right? Their height is a little short for their shoe size. I would expect a higher compared to everyone else. But you also have to take into account every single one of these dots. Okay? So I'm going to teach you today is how to graph that. One of the things I'm going to teach you today is how to graph that. Well, first of all, what I want you to do is kind of come up with a sketch. What would a line look like starting on this axis? What would a line look like that best fits all the data? What would a line look like? I want you to sketch it. Just sketch it lightly, and then we'll give you the right answer. I'll give you the right answer in a little bit. What would a line that best fits every single one of these points look like from edge to edge? Would it look like that? Would it look like that? Would it be down a little bit more because of those 2 points? What would it look like? That's what I want you to do. Just sketch it. Sketch it on there lightly. You don't have to sketch. Don't do it really dark because you might erase it later. Because I'm going to give you the real answer here in a second. Okay. Okay, so how do we come up with the actual one? Well, we have the equation, right? We have the equation here. The y-intercept is almost about 54. So we would go up 54, make a dot. And then here's the slope. So we would go up 1.462 over 1. But I don't have any numbers here, right? There are no numbers here. So the calculator will do it. So I'm going to show you how to do it on the calculator. Okay, so grab a calculator, go to a blank, or get out of this. So if you're here, how do I get out of this? So I want to get anywhere but this. I don't need this anymore. Second mode, here you go, right? That always gets you back to the home screen. Good. Second mode. Okay. So what I want to do is I have to calculate A, B, and R again. Okay, my calculator your calculator has a memory, but the memory, I don't know, that was yesterday, so I don't know if my calculator has those numbers in its memory. I don't want to assume it does. So how do you get it back in its memory? You calculate them again. Okay, we already have the data in L1 and L2, right? So we're going to go stat, calc, linreg, not the first one, the second one, hit enter. This is what we did yesterday, okay? L1, my X list is in L1, my Y list is in L2. So just keep hitting enter. See where it says store reg equation? When you hit enter, it doesn't seem like it does anything, but it actually does something. It remembers, it stores it in its memory. Okay? So when I hit enter, it's going to remember all of the numbers that it's going to show me right now. It's going to remember all of these numbers that it shows me. Okay? I already wrote down these numbers, so I don't need to write them down again. But it was important for the calculator to remember them. Okay. So once you've done that, now we're going to go back to the actual list. Go back to the actual list. Or actually, no, don't go to the list. Sorry, don't go to the list. Go to, where is it? Go to this button right here. We haven't used this function before. It's called vars. It's right underneath clear. It's right by clear, right to the left of clear. It's called vars. From here, it's pretty obvious which one do you think we're going to go to? Look at the list and which one do you think we're going to go to? Statistics, right? This is statistics class. We're going to go to statistics. And then you see the one on top that says EQ, that means equation. So we're going to go over to EQ. And we're going to use this regression equation. Okay, that's the equation right there. That's the actual equation. Okay, you don't need it right there. We need to graph it because we want to see where it's going to be on the graph, right? Okay, so we didn't need to do that. I just wanted to show you where it was. So this is what you're going to do now. We want to graph a line. This is probably the only time in this class, definitely the only time in this class we're going to graph, but not using stat plot. We always graph using stat plot. This is the only time we're not going to use stat plot. Why is that? Because we need to graph an actual line regression line. So anytime you're graphing lines, you graph here. So y equals, go to y equals. Okay. We need to go find that equation again. I erased it. So we need to go find that equation again. So we're going to do the same thing we just did. We're going to go to vars, statistics, EQ, number 1, regression equation. Hit enter and it'll appear. This time it appears as a graph. This is the equation. Okay. Now we need to see that equation. So let's go see it. Go to zoom stat. Zoom stat. So here's your old equation plus the line there. Okay. So compare that with your picture. Fix your picture. Okay. Huh? That's it. Let's go to vars. Go down to statistics. Go EQ. Oh, okay, so your calculator forgot. So go calculate it again. Remember how we calculated it? Calc. Oh, do you have the numbers in L1 and L2? Oh, you do? Okay. So let's see. So go down to linreg. There you go. Hit enter, 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 enter. Okay. Now go to y equals. And then go to the same thing. Go to vars. There you go. Just the calculator forgets sometimes.
How do you make the graph?
You go to y equals. Y equals. Okay. So if you forget how to do it, it's on. You can watch the video on to see how we did that. That's why I record it, so you can watch it later. Okay, so this is what it looks like. Okay, here's my question, and here's the test question. Why is that the line? Why is it not the one you did earlier? Because no one's was exactly right. You guys were off by a little bit, maybe. You guys are pretty close, probably, if I looked at your lines. But why isn't it look more like that? Why doesn't it look more like that? Why isn't it down a little more like that? Why did that one why did they choose that one instead of the ones I just showed you? Why didn't they move this blue line a little bit down to be like that? Why did they choose that line? Mhm. Mhm. Yeah, it's actually there's an actual specific reason involving calculations that says it. It's the reason why we call it the least squares regression line. So what they do, what the calculator does, calculator is amazing because what it does with when you just hit enter is it calculates this distance, the distance between all of the dots and the blue line. 31 distances. Some are close, some are far. And it says which blue line would be the best in terms of limiting the amount of errors. Errors are these. These red lines I'm drawing, these red segments I'm drawing, they're what we call errors. There's 31 errors. That distance from the dot to the blue line is called an error. It has another name, but for right now, we'll call it an error. What it does is it says, give me a blue line that limits the amount of red there. So if I were to move that blue line anywhere else, it would increase the amount of red. So that blue line represents the least amount of red you will see. That's why it's called the least smallest errors squares regression line. Okay. Okay. So, okay. So what those red, they're called errors. They are errors. What does the blue line represent? What does the blue line represent again? What's that? Okay, but more specifically, not perfect. There's another word that starts with a P that we talked about yesterday that it actually represents. Yep. What's that? It's the predicted line. It's the predicted line. What do each of those dots represent? Actual students in the class. The dots were actual students that were sitting in your seats last year or the year before. I can't remember. They were the ones whose those are. That's actual. The blue line goes through maybe 1 point, maybe 2 points exactly. That's what I predicted based on the data that I had. So not everyone is what they predicted the line predicted to be, but it best fits all of the points, right? It best fits all of the points. So what are those red called? What are those errors called? Another name for them is called residuals. Residuals. Okay? That's another name for it that you will see. They're errors, but you will see it being called residuals from now on. So the residuals, what is a residual? It's the difference between what I observed and what we predicted. The difference, the length of these red lines here, the length of these red lines, right? That's what a residual is. Believe it or not, our best fit line will miss most of the points. It missed most of the points. That'll happen. Okay? So what we have to do is calculate what's called a residual. So how do we do that? Well, we subtract two numbers. You subtract the observed y, what actually happened, minus what we predicted. Okay, it's called a residual. All right. So let's find a residual. Okay. So here we go. E. What is the residual value for a person who has a shoe size of 7? What is the residual value for someone who has a shoe size of 7? Okay. So my formula says take the E value or take the Y value and subtract it from the predicted. Okay. All right. Easy enough. So residual equals for a shoe size of 7, what's Y going to be? How do we find that out? Or how do we calculate that? Or how do we find that? Or how do we look? How do we find the observed Y? Mhm. You look at the table, right? You look at the table. Let's go look at the table. Observed means actual. Observed means what actually happened. So the observed of someone who had a shoe size of men's 7. Well, let's see, I have one here, I have one here, and I have one here. I had 3 different people in the class who had a shoe size of 7. One of them was 64 inches tall, one of them was 66 inches tall, one of them was 63 inches tall. Okay? Which one do I use? Well, you use each of them. I don't average them. I don't take anything like I don't say, oh, they're all around 65 or 64. No, you're going to have 3 residual values. So we need to calculate all 3 residual values. Okay? I'll do the first one with you. So let's do this person right here. 764. 764. 7 comma 64. That was that person there. So what is the observed Y? 64. Good. Minus the predicted Y. What was the predicted Y? How do I figure that out? Use your equation. So someone who has a shoe size of 7, what would I predict? What would my blue line predict their height would be? Use your equation. We did an equation. Doesn't this say predicted height? That's what we're trying to find, right? Predicted height. So tell me someone who has a shoe size of 7. What would my blue line predict them to be? How tall? So my equation was 54.07 plus 1.462 times shoe size. Well, multiply first. 1.462 times the shoe size was 7 plus 54.071. I would predict them to be 64.305. $64.305. So we subtract those and we get negative 0.305. So that's the residual for the person who is 64 inches tall. Shoe size 7, 64 inches tall. What I want you to do now is find the other two people. Find the other two people. Find the residual for the other two people. Uh-huh. I multiplied, then I added. Look at your notes. Look at your notes. You should see that number on your notes from yesterday. Where do you see it for? For B, right? It came from the equation, right? I just used the equation. All I did was use the equation to get the predicted, because that's what it said it equaled. It said it equaled the predicted height. So all you had to do, you didn't even have to multiply anymore. You just had to subtract. We did the 64. The next person was 66. That's how tall they were. So I just plugged in 66, subtracted the same number, plugged in 63, subtracted the same number. Two of them were negative, one of them was positive. Why are two of them negative, one of them positive? How do I know if I'll get a positive answer or a negative answer? That's what I should ask. How do I know if I'll get a negative answer or a positive answer when I'm trying to find residual? Yeah, exactly. If the predicted is bigger than what actually happened, like this guy here and this guy here, if I predicted too high, they're going to have a negative residual. The middle one, I didn't predict high enough. The person was taller than what I predicted. So they're going to have a positive residual. All right. So let's go back to the picture. Erase all of these guys here. Okay. This guy here. These two guys here. Green guys. Are they going to have a positive or negative residual?
Negative.
Why negative?
Below the predicted.
So it's below the predicted. So which one's higher? Which one is higher for the green guys? The predicted or the actual? Predicted is higher. So if predicted is higher, is it going to have a positive or negative residual? Negative residual. Yep, negative residual. So all of these guys underneath are going to have negative residuals. All of the guys over on top are going to have positive residuals. Positive residuals. Because they'll ask you that on the test. They'll be like, this guy right here. They'll add something. They'll be like, this guy right here. Is that guy going to have the biggest residual or the smallest residual? Well, it's going to have the biggest because the actual was a lot higher than what actually happened. Okay. Should I make the class harder? If there's time for conversations between the middle of this, I'll make it harder then. Okay. All right. I want you to do F. I want you to do F. What is the residual value for someone who has a shoe size of 10 and a half? Okay. Find the residual of stuff to do 3 calculations like you did last time. You just have to do 1. So what minus what? 68 minus 69.422. All right. Let's see. Let me write that down. 68 minus 69.422. And we get negative 1.422. Did I predict too high for that person or too low for that person? That person was 68 and I predicted 69.4, so I predicted too low because it's below the line. Okay. Okay, so now what we're going to do is we're going to do just like that. We're going to calculate all of these guys for every single one of those points. So right now we just did 4 of the points, right? We did 3 people who had a shoe size of 7 and one person who had a shoe size of 10.5. What if I asked you to find the residuals for the other 27 people? You could do it, but it would take you probably to the end of class and maybe a little bit tomorrow too, right? Okay, I'm going to show you how to do it faster. So you don't have, you can do it by hand, 100%. You don't need this, but it takes you a little bit longer to do it. Okay, so what we're going to do is we're going to calculate the residuals for everybody. Okay, so I need your help. I'll tell you how to use the calculator, but you got to tell me what to do, how to find a residual. Okay, so we're going to go to our first thing, we're going to go to our list where our numbers are. I should have two lists right now. Okay, one is the shoe size and one is the heights. We're going to create a third list. That's going to be our residuals. So you're going to go to L3. You're going to go to the top. Look at what my cursor is. Look what my cursor is. You're going to go to the top, hit enter. Then you should have a little blinking light at the bottom, a little blinking cursor at the bottom. It means it's ready to input stuff. We're going to create a third list. That list is going to be the residual. So tell me again, how do I calculate a residual? You just did it 4 times. How do I calculate a residual? What do I do first? You just did it 4 times. Tell me how to calculate one residual. Okay, so y minus the predicted, right? Where's our y? L2, aren't those our y's? So what we're going to tell the calculator is I want you to take all my observed y's, subtract it from my observed, right? So I'm going to put parentheses here. How did I get my observed? You did it 3 times. How did I get my observed? What did I do to get my observed? Or sorry, no, predicted. Sorry, predicted. What did I do to get my predicted? Well, yeah, what is that called? Plugged it into the equation, right? Plugged it in the equation. Doesn't my calculator know the equation? Didn't it already show me that it knows the equation? I would like the equation right here. So let's go back and do the show me the equation. Have it show me the equation. Hopefully it still remembers it. So how did I get the equation again? Vars, good. Keep going. Good. Good. Hopefully my calculator still remembers. It does. I plugged in. What did I plug in and where did I plug it in?
Plugged in the equation.
I have the equation. Check. Well, where did I plug it in? And what did I plug in? I plugged in X, shoe size, into X. I want to do that, but I want to do that on a mass scale. So I'm going to tell my calculator parentheses, because parentheses mean multiplication. Instead of just plugging in one number, I want you to plug in the whole batch of numbers. Close parentheses, and then close parentheses because I use double sets of parentheses. Hit enter. There's all your residuals, all 31 of them. Let's see. We know 4 answers, right? Don't I know 4 answers already? I already calculated 4 answers. I said the person who has 7, shoe size of 7 and 64. I already calculated that number, right? What did I get as an answer when I calculated it? It's right there, right? You guys just said you guys had different things. Okay. Okay. Then look up here. Look up here. Okay, don't worry about your calculator. If calculator's causing issues, look at that. Look up here. Okay. Seven, shoe size of 7, 66 inches. Shoe size of 7, 66 inches. We said that was 1.695. 1.695. Shoe size of 7, 66 inches, 1.695. There it is right there. Shoe size of 10 and a half was negative 1.4 or something. There it is, negative 1.422. Okay, that's how to calculate residuals quickly. Could I have done this by hand? Yeah, you could have done it by hand, but it would have taken a little longer. Okay, so now what I want to do is graph those. So what I want to graph is x versus y. X versus y. Okay, so my graph is going to look like this. Watch, I'll show you what my graph's going to look like before we actually tell the calculator to do it. So this is what my graph's going to look like. You're going to have a graph that looks like this. The x-axis is going to be the x's. The y is actually going to be residuals. Okay. So what was x again? Remind me what was x? What was x though? What was it? What was it? Shoe size, right? X was shoe size. That's right here. 1, 2, 3, 4, 5, 6, 7, and just keeps going, right? That's shoe size. Residuals. How far was I off? What were my errors? That's what there. Okay, so what we're going to do is graph that. So let's go make a scatter plot. Let's go make dots. So scatter plot. Second, stat plot. What do I want to graph? What's going to be my x? Okay, so how do I tell my calculator? I can't type in shoe size on my calculator. L1, so we'll leave x the same. Okay, so the y is going to change. What do I want to tell it to be now? L3, my L3. If you're not in L3, don't put L3. I put it in L3. Some of you guys had it in a different list. That's fine. But just tell the calculator that, because the calculator doesn't know that unless you tell it to. Okay. Now go to Zoom Stats. There you go. That's your residuals. That's called the residual plot. It's all of the residuals. Everything above the x-axis has a positive residual. Everything below the x-axis has a negative residual. Okay, so I'm going to draw that on my graph. I'm going to draw it best I can on my graph just to give it a good picture. Okay. So just a sketch of that. Just drew a quick sketch of it, what my calculator said. So x was actually shoe size. So instead of x, you can write x, but we should actually put shoe size here because that's what it represents. You could put x too, it's okay. And then y up here. But that's what they are. Okay? Okay. So if you were going to say yes or no, does this have a pattern to it? Is there a kind of pattern to it? Would you say yes or no? Is there a pattern to what you're seeing? It's getting closer to the line. What does that mean? If it's getting closer to the line, what does that mean? You're right. It kind of flares out and then kind of gets closer as shoe size gets bigger, right? So what does that mean? As shoe size is getting bigger, what's getting smaller? The errors, yeah. So for the people that are tall or have bigger shoe sizes, I was more accurate. That's what it's saying. I was more accurate. My blue line was more accurate. Wasn't so accurate for the people who have small feet. Okay? That's one thing. So if you're not sure, yes or no, if it has a pattern, look at down here. Look at the dots in the underneath the red arrow. That's a pattern. Those are the types of patterns I mean. Right? Now those are like extreme patterns, but is it more like the blue dots or is it more like the black dots? Which one is my picture? I would say it's more scattered like the blue, right? There's no real pattern. What that means is no pattern is good for a residual plot. This is only for a residual plot. No pattern is good. It means a linear model is appropriate. It means you can have confidence in using the equation. I can have confidence in using this green equation. Okay? If you didn't, if I got a pattern, that means it's not good. It's not appropriate to use that equation. Okay? So there's a lot of shuffling around going on. I'm going to stop right there because I feel you're missing something. Okay? It doesn't take you 4 minutes to back up. I bet you if I gave you 30 seconds to back up, you guys would have 25 seconds to spare. Okay? Let me finish and then I'll let you back up. Okay? So, what does this mean? Because this is very extremely important. Patterns mean a linear model is not appropriate. It means another model is appropriate. An exponential model, a quadratic model, some other model that we don't talk about in this class. All we need to talk about is a linear model the best model? If there is a pattern, nope, not appropriate. One of those other ones are better. If it's not, if there is no pattern, kind of like points everywhere, can't really predict what's going to happen, that's good. That's what we want. Okay, why is a pattern bad? Why is a pattern bad? Well, look at this pattern. If I were to continue this pattern, where would the dots go? Up, 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 up. Is that good if the dots go far away? It means my errors are getting bigger and bigger and bigger and bigger. That's not good, right? If I'm going to predict something, I better not have big errors. Same things down here. This guy keeps going down, down, down. I'm going to have, my errors are just going to get bigger and bigger and bigger. That's why it's bad. That's why it's bad. Okay? We want something that's unpredictable. If I kept going in shoe size, I don't know what would happen to those dots. Getting closer to the residuals is actually good because that means I'm getting better with my prediction. Okay? So no pattern means linear model appropriate. Okay, that's what we're looking for. That's only on the scatter plot. That's only on the scatter plot. That's not, or sorry, that's only on the residual plot. A lot of people get this one confused with this one. They're completely different. Okay, that's what we're going to work on the rest of the week. All right, thank you guys. Okay.